Hello, everybody. This is Bert Dixon here presenting today on the topic of right triangle similarity and the geometric mean. So we'll start with the geometric mean. Here's a definition. A geometric mean is just the square root of two numbers. So if you want to take the geometric mean of A and B, that is the square root of A and B. Okay, another way to look at that is the letter C is the geometric mean of A and B if C squared is equal to AB. So we see that if we take the square root of both sides, we get the same thing that we did up here. So it's just another way to write it. So basically what we're doing when we're finding a geometric mean is we're finding a number that we can square that has the same product as the other two numbers. Okay, so as an example, to find the geometric mean of 3 and 12, the geometric mean is equal to the square root of 3 times 12. So that's the square root of 36, which is 6. So the geometric mean of 3 and 12 is 6. Then we can do the same thing for example B. If I want the geometric mean of 2 and 9, the geometric mean is the square root of 2 times 9. So that's the square root of 18. And then we can simplify that because the square root of 18 can be broken down as, since it's 9 times 2, then we get 3 square root 2. Square root of 9 is 3, and the square root of 2 is just the square root of 2. So we get the geometric mean is equal to 3 root 2 in that case. Okay, so you go ahead and try these two in your groups. Go ahead and pause the video. And after you have had a chance to try both of these, then press play. Okay, so to find the geometric mean of 2 and 8, the geometric mean of 2 and 8 is the square root of 2 times 8. So that is the square root of 16, or 4. So our geometric mean is 4. For part B, the geometric mean of 8 and 9 is the square root of 8 times 9. That's the square root of 72. And to break down the square root of 72, we're looking for a perfect square that goes into 72, and that is 36. 36 times 2 is 72. The square root of 36 is 6 times the square root of 2. So the next topic is right triangle similarity. And what we're going to look at is if we take a right triangle and we draw the altitude from the right angle to the hypotenuse. So an altitude, remember, always forms a right angle with the opposite side. So there's an altitude. We'll call that point D. What that does when we draw the altitude to the hypotenuse in a right triangle is it divides the triangle up into 3 individual triangles. So we have the small triangle on the upper left, we have the medium triangle on the lower right, and then we have the big triangle, the original triangle ABC. So what we're going to show is that those 3 triangles are all similar. And so to do that, I'm going to draw the 3 triangles, small, medium, and large, all with the same orientation so that it's easier for us to match up the corresponding pieces. So we have small, medium, and large right triangles. Okay, so in the smallest triangle, that's this one right here, the right angle is at D. The short leg goes from D to A, so that's this, from D to A, so this would be A here. And then the hypotenuse goes from A to B, so this must be point B here. Okay, so this hypotenuse and this hypotenuse are the same thing. Okay, and then in the medium triangle, we have, again, the right angle is at point D. Now this time the short leg goes this way from B to D. B to D, or D to B is the short leg. And the long leg goes from D to C, and that means the hypotenuse goes from B to C, which matches what I have, and the right angle is right there. And then for the third triangle, that's the big one. Okay, Our right angle for the biggest triangle is at B, and the short leg goes from B to A, and the long leg goes from B to C, and there we get the hypotenuse that goes from A to C. Okay, so now we have all three triangles drawn, and to show that they're similar, I want to point out that angle A is right here. So let's call that angle 1. So that angle is here, and it is here. So those two triangles are similar because they have a pair matching angles there, angle 1 and angle 1, as well as the right angles here and here. So those two triangles are similar by AA. Okay, so now we know the small one and the big one are similar. And then we can do the same kind of thing with the medium-sized one. Let's call this angle 2. So angle C is angle 2, so we have angle 2 and angle 2. And so both the medium and the large triangle have angle 2 is the same, and they both have a right angle. So those two triangles are similar by AA. So we showed that these two are similar by AA. Then we showed that these two are similar by AA. So that means they're all three similar to each other. So now that we know the triangles are similar, we can use an arrangement like this anytime we want to find, if we're given some of the lengths, we can find other lengths by using this similarity proportion. So I've got several examples here. Go ahead and draw a rough sketch of this one, problem 1. It's got the right triangle as well as the altitude drawn to the hypotenuse. Okay, so as we did in the previous problem, what I want to do, in order to approach all of these, I want to draw our three triangles, small, medium, and large. The orientation that you pick doesn't matter as long as we use the same orientation for all three. Okay, so for this triangle that's up on the top here, our hypotenuse is labeled X, and we don't know anything else in that small triangle, or in that, that's not necessarily the smallest one, but it's the triangle up on the top. Okay, the triangle down here, which may be actually smaller, doesn't matter which one is small or which one is large. What we want to recognize is that the short leg for this one is 25. And then for the biggest triangle, we have a hypotenuse of 64. And X is the, we said X is the hypotenuse of this smaller triangle. And X is also the longer leg of the big triangle. Okay, and so now we also recognize that since this is 25 and this is 64, the difference between those is 39. And so we know this side is 39, so that would be, this is 39. And so now we can write a proportion to solve for X. So look at the first triangle and the third triangle. Both of those have hypotenuse and vertical leg. So if we do vertical over hypotenuse equals vertical over hypotenuse. The vertical piece is 39. The hypotenuse is X. For the smaller triangle, for the bigger one, the vertical is X and the hypotenuse is 64. And so now when we cross multiply, we get X times X is X squared equals 39 times 64. And so then X equals the square root of 39 times 64, which is, the square root of 64 is 8. 39 doesn't have any perfect squares that go into it because the only numbers that go into 39 are 3 and 13, and neither one of those is a perfect square. So that's it. That's our answer. X equals 8 root 39. So again, we did that by arranging all of the triangles with the same orientation, decide what's the short leg, what's the long leg, what's the hypotenuse, and fill in all the matching pieces. Okay, so this does take a little bit of practice. I'll do another one with you and then have you try some. Okay, so let's look at this example 2. Go ahead and draw yourself a rough sketch of this one. And then again, we're going to draw our 3 triangles, small, medium, and large. Okay, looks like our small one is down here, and it looks like we don't have, we're not immediately given any information about that one, except that if this is 56 and this is 81, then this would have to be 25. And so that's the short leg of this small triangle is 25. We don't know anything else about that one. In the medium triangle, that's this one, we know the hypotenuse is labeled as X and the long leg is labeled as 56. Okay, and then in the biggest triangle, we have the long leg is labeled as X and the hypotenuse is labeled as 81. So now we would choose, since we have 2 pieces in these 2 triangles that correspond to one another, in both of them we have the hypotenuse marked, and in both of them we have the long leg marked. So now I can do something like this. Hypotenuse over long leg equals hypotenuse over long leg. Okay, or if you flipped it and did both of them upside down and did long leg over hypotenuse equals long leg over hypotenuse, that would be okay too. The order doesn't matter as long as you do both proportions the same way. So I'm doing hypotenuse X over long leg 56. That's in the first triangle. And then in the second triangle, that would give us hypotenuse 81 over long leg X. And so now when I cross multiply, X times X is X squared equals the square, or equals 56 times 81. And so X would then be the square root of 56 times 81. So that should look somewhat familiar. That is, X is the geometric mean of 56 and 81, and that's what we learned at the beginning of this lesson. So X is the geometric mean of 56 and 81, and so now we just need to simplify that. The square root of 81 is 9. Now 56 can be broken down because it's 4 times 14. 4 times 14 is 56. And so that's going to be 4 times 14. So we get square root of 4 is 2, root 14. So altogether we get 18 root 14 when we simplify. So X is 18 root 14. And we do want to simplify those because it says leave your answer in simplest radical form. Okay, it's time for you to try one. So I would like you to draw a sketch of this one. Go ahead and pause your video and press play after you've attempted the problem on your own. Okay, so for this one, again, I'm going to draw our 3 triangles. So we have 1, 2, 3, small, medium, large. I'm going to call this one down here our small one. And in the small one, we have our short leg is X and the long leg is 12. In the medium size triangle, that's this one up here, we have the short leg is 12 and the long leg is 16. And for the biggest triangle, this one, the hypotenuse is x plus 16, but we don't have any other pieces for that one. Okay, so we're going to use the triangle where we have two of the pieces of information given that correspond with each other. And so if I set up a proportion here, I could do something like long leg over short leg equals long leg over short leg. So again, it doesn't matter what goes on top and what goes on the bottom as long as you're consistent. So if I wanted to do short leg on top and long leg in the bottom, I'd have to do that for both of them. So the way you set up the proportion doesn't matter as long as you're consistent, meaning you do it the same for both. So if I put the long leg on top and the short leg on the bottom for the first triangle, then I have to put the long leg on top and the short leg on the bottom for the second triangle. Now when we cross multiply, we get 16x equals 144. And so x equals 144 divided by 16, and that is 9. So x equals 9. You see here again the connection between the geometric mean. 12 is the geometric mean of these two pieces. So that is always true. The altitude drawn to the hypotenuse is always the geometric mean of the two pieces here. So we got 9 as an answer. When you multiply 9 and 16, you get 144. When you multiply 12 times 12, you get 144. So that means 12 is the geometric mean of 9 and 16. So that's the connection between the geometric mean that we learned at the beginning of the lesson and what we're doing with the similar triangles. Okay, so in any of these, you can always check your answer and see if it turned out right, because this side, if we call this A, and we call these two pieces B and C, A is always the geometric mean of B and C. So the altitude to the hypotenuse is always the geometric mean of the two pieces of the hypotenuse. Okay, so you can always use that to check your answers. So for example, we could go back to problem number, well, let's see, we didn't find, no, we can't check that in problems 1 and 2 because we didn't find the length, we weren't asked to find the length of the altitude. Okay, but you will be able to in example 4 when you get done with this one. So go ahead and copy this one down and give it a try. Pause your video and then press play after you've tried the problem. All right, so for this one, again, we're going to draw our 3 triangles. So we have small, medium, and large. The 3 right triangles. And in the smallest one, that's this one over here, we know the short leg is 16 and the long leg is 4 root 65. In the medium triangle, we know the short leg is 4 root 65 and the long leg is x. And in the biggest triangle, the only measurement we know is that this is x plus 16. We don't have either of the legs for the biggest triangle. Okay, and so now setting up the ratio, if we do height over base equals height over base, then from there we would cross multiply and we'd get 16x equals 16 times root 65 times root 65. So I did 4 times 4 is 16, and root 65 times root 65 is just going to end up being 65. Root 65 times root 65 is just 65. And so then we have 16x equals 16 times 65. So if you divide both sides by 16, those are gone. And then you just get x equals 65 as your answer. And so if x is 65, then we can look at that, the geometric mean relationship that I was talking about. If this is 65 and this is 16 and this is 4 root 65, this squared should equal 65 times 16 if we did everything right. The altitude to the hypotenuse is always the geometric mean of the two pieces of the hypotenuse. So if I do the left side with my calculator, 4 square root 65, I'm going to square that. That gives me 1040. And if I multiply the right side, 65 times 16, I also get 1040. So that's just a way we can double check our work and see that the answer that we got is correct. So that's it for today's lesson. Go ahead and try the problems that are in HRW or in the book, and let me know if you have questions. Have a great day.